So the sensors connect to the gateways. And then these gateways connect to the cloud, to the internet. These are called layers. First layer, second layer, and third layer. So a typical Internet of Things architecture consists of the following. The perception layer. We have cameras, robots, sensors, etc. The transport layer. Transport layer used for transmission of the data from the sensor onwards. We have the processing layer. Here, the data that is produced by the sensors is stored and processed. And then we have the application layer. We have an application on our mobile phone, on our smart watch, to inform us about something, to inform us about, give us some alerts about what is happening in our smart home, etc. So perception, this is the hardware layer. Sensors, connected devices, and actuators are all here. Network, data goes through this layer, so it connects the perception layer with the application layer. Data and gateways are the main players at this layer as they bring the message to the backend service of IoT applications. We have the process layer and also the application. So someone will now ask, how can we select the right sensor, the right Internet of Things sensor? And we can see here that we have here the humidity, temperature, light, etc., etc. This is what we want to sense, what we want to measure. Here we have the method of wireless transmission. We can use Bluetooth, Zigbee, 5G, Z-Wave, LoRaWAN, NB-IoT, etc. And also, how are these things going to be powered? Are they going to be powered by batteries? Are they going to be powered by solar? Are they going to be wearable, implantable within our bodies, smart, modular? Are they going to be disposable? And also here, if they have embedded any processing technology. So here we have different types of sensors, temperature, chemical, gyroscopes, optical, gas accelerometer, level, proximity, noise, motion, light, moisture, etc. There are dozens types, hundreds types of sensors, depending on the application. So depending on the application, we will install specific sensors for specific applications. So these IoT sensors, we can install them for transport and logistics. For example, in a car, measuring the GPS, the speed of the car, to measure the temperature within the lorry. We can measure the consumption and the voltages of our grid. We can use it in clever parking sensors. I think you've all been in parking spaces now that they count how many cars they are in and how much space is available. So they have parking sensors. And for smart home and home automation, we have sensors like alarm systems, smoke detectors, etc. We also have other like environmental monitoring. We can use them for smart agriculture and precision agriculture. We can use it for industrial purposes, for monitoring production lines, etc. And at the same time, we can use it for our own good, our own health. All sensors, all Internet of Things sensors require a gateway. And so we have here Wi-Fi and connects to the gateway. We have Bluetooth, it connects to the gateway. We have sub-gigahertz sensors, they connect to the gateway. We have Ethernet storage, it connects to the gateway. So the gateway is the means of connecting our sensors to the internet. So a typical function of the gateway is this. We have the devices here, we have the gateway here, and this is in between the cloud and our devices. This is a very typical, simplistic way of doing this, of presenting this. So IoT gateways, so in what frequency they work, it depends on our own device. So our watch, for example, it has Bluetooth. So our gateway could possibly have Bluetooth in order to act as a gateway. And some sensors are for smart home, they are Wi-Fi sensors. So our gateway should have Wi-Fi. Okay. So these, I'm talking about Wi-Fi and Bluetooth because these are the most typical things you will find in Internet of Things. You can also have Zigbee. Zigbee is another popular wireless transmission protocol. But as you can see here, they are not all the same. They have different characteristics. So we all know that Bluetooth has a very short distance, up to 10 meters. Wi-Fi could go to 100 meters. Bluetooth is very slow compared to Wi-Fi. Wi-Fi draws a lot of power. Bluetooth, we can use Bluetooth in our headphones for 8 hours. It's fine. With Zigbee, even less power, less distance, but less power consumption as well. We also have LoRa. LoRa is another popular method for transmitting. Here in Europe, we use this frequency, 868 megahertz, for transmitting data. Here we can go up to 10 kilometers or even 100 kilometers distance. So this is 10 meters. NB-IoT is provided by the telephony network. And depending on your cellular phone provider, depending on your country, they might offer the NB-IoT. So it's embedded NB-IoT, and 5G is offered by telcos, by telecom operators. This is this could be within our house. We can buy this. This is offered by telcos, and this could be offered by third parties as well, by third parties. Another way, another thing is important. It's not only the wireless transmission method, but it's the communication method. These are called IoT protocols. One of the most popular IoT protocol is the MQTT, and we will talk about it in a bit. And I would say MQTT is designed, it's excellent for communication, as a communication protocol for Internet of Things. So please check out more things about MQTT. I will talk about MQTT in the next slides and also in the more advanced presentations that we'll have later. So for a typical For a typical smart home, we will have multiple sensors, but we could have one gateway or so this here, it's a small gateway. This is a small gateway. It's very tiny, it's small. And this thing, it has Bluetooth, it has Wi-Fi, it has also Zigbee. So you can connect your sensors directly to it and then access these sensors via your mobile phone, via the internet. So this is a typical gateway. So this is how a small gateway for a house looks like. So this device here that I have in my hands, it's a temperature humidity sensor, wireless temperature humidity sensor that is connected with Bluetooth. So our Bluetooth, small Bluetooth this device, which has a very small battery in it, it connects to our gateway and then to the internet. So by doing this thing with the gateway, we can have low power devices, cheap devices. This is less than 10 euros. Okay, this is then less than 10 euros. And we can monitor our house remotely and understand what is the temperature if in our room, the temperature in everywhere in our house. Very easy. Or you can use this in your greenhouse if you have any. This, on the other hand, that I have in my hands, it's a March. Okay. That's okay. Anyway, let's move on. Another thing which is very important is edge devices. Till 5 years ago, nobody knew what was edge. So an edge device is a device that we can use to process data before they are uploaded to the cloud, before they are uploaded to the internet. So imagine that we have hundreds of sensors in our house, and we have to process all this data to the cloud. There is a lot of bottleneck there. So edge devices, they pre-process the data. They pre-process the data before they reach the data center. So they don't upload all data to the data center. They upload only the necessary data. So one very important part of the Internet of Things is the data center. So the data center is a place where data are stored, data are processed, and also through this data center, we can access them using our devices, our apps, etc. So why the cloud? Because the cloud is a centralized platform. We can use it for data aggregation, storage, large-scale processing, and analysis. They are scalable, flexible, and they have enhanced computational power. And at the same time, they are accessible from everywhere. Okay. So a typical example of cloud computing related to the Internet of Things is for a smart city. So for a smart city, we have lots of sensors, measuring the traffic, the communications for the hospital, for the smart grid, etc. And then all these, they are uploaded to the cloud. Another important thing related to the Internet of Things is for the healthcare systems. They monitor the patient, blood pressure sensor, body temperature sensor, SpO2 oxygen saturation sensor, respiration rate sensor, ECG sensor, heart rate sensor. They pre-process the data here on our mobile device, on our smartphone. And then after that, they are stored in the cloud. So this is how a typical IoT infrastructure looks like. We have the sensors, we have the actuators, we have the gateway, which communicates through MQTT and Wi-Fi and all Bluetooth, whatever. We have the IoT platforms through which we manage our devices, etc. But what happens with the security of Internet of Things? Imagine if someone could potentially access our sensors at home. So there will be, it's important for the devices to be secure, not to be accessible by everybody. Someone could tamper with them. Also, the communication is important. We don't want someone to press the remote control and instead of opening his door, our door opens. So communication is important. And also, it's important to have secure cloud. So to make sure that nobody has access to our account in the internet. So this is, it's important for IoT to be secure. So for example, in a smart home, we have keyless entry. Imagine if this device was not secure. Or if someone could change the behavior of our motion detection. Or someone could stop the alerts on our smartphone. Another important thing we have for Internet of Things, they are called wearables. We usually call wearables these smart watches that we have that they measure the oxygen saturation, the heart rate, etc. But also smart glasses are wearables. There are also smart trousers. They're not a lot out there, but they actually exist. But they say that in the upcoming years, these wearables will be even more, albeit the most popular ones are these wristbands. Okay. Smart shoes. Have seen many smart shoes, especially for athletes or for rehabilitation purposes. They have internally sensors, and they measure acceleration, they measure pressure, etc. But IoT comes with many, many issues, and it has many, many challenges. As you can see, as we saw before, there are many wireless communication protocols. There are many manufacturers producing IoT devices. So we have scalability issues, security and privacy concerns, interoperability between devices. This is possibly the most important thing. So if you buy that gateway that I showed you before, that gateway could be, it is possible that it's not compatible with all Zigbee devices. It's not compatible with all Bluetooth devices. So they say, if you want a Bluetooth gateway, you have to buy my Bluetooth gateway. Otherwise, it will not be compatible with our devices. So these manufacturers, they have these issues with interoperability. At the same time, a problem that it's a real problem is many of these devices, they mention that they last for 5 years, but instead of 5 years, they last for 5 months. Okay. We also have other applications of IoT that are related to the environment. We can have smart energy management for our home, air quality monitoring, smart waste management. Some countries, they have these smart bins now, when automatically it informs the local authorities that those green bins are full, and they inform them to go there and pick them up instead of going there to pick empty bins. We have smart water monitoring. A lot of water is wasted, leakages, etc. Fleet management for cars, smart and precision agriculture, cold chain management. So Internet of Things can definitely help, if applied correctly, can definitely help for sustainable environment and the SDG goals of the United Nations. It can also help for the society to make a better environment, to have a cleaner environment, to have lower noise. If you measure something and you know that the river is polluted, if the city is noisy, if there is pollutants in there, then you are able to take action. Okay, so it has impact to our society. But at the same time, ethical considerations arise. Imagine if everybody has IoT devices on them, wearables, and someone could possibly follow them around because of bad design of that IoT device. So there are many ethical considerations of who can access this data. One of the things that will move the Internet of Things forward, they consider 5G that will help for this, and it will help for the automotive industry, especially the 6G. They say that it will help for autonomous cars. So today we have 5G, and the upcoming 6G, they believe that it will help for automated car driving and the factors of the future, energy, etc. So, and e-health, etc. So all these wireless technologies, they tend to help the evolution for Internet of Things. As you can see here, back in 2019, we had around 27 billion devices installed. And next year, it is estimated that we have 75 billion devices installed. Billion devices. Imagine that we have 7 billion, and how many billion we have in? It's a lot, it's a very big number. So that big number means that developers are rushing to produce IoT products that are not properly secured. Everybody saw that, we are going to have 75 billion of devices, so we have to produce Internet of Things devices. So they produce these IoT devices, they are not secure. So there are a lot of issues related to this. IoT products on the market are vulnerable to attacks. 70%. So this is something to consider. We need more engineers and scientists and IT engineers. Rural areas lack reliable connection or any connectivity. 40%. Anyway, future predictions. 90% of senior executives in media companies believe IoT is critical to their growth. 66% of US cities are investing in smart city and IoT technology, and it is believed that for the healthcare industry, by using IoT devices, remote health monitoring, remote patient monitoring, they will be able to have savings up to 25%. So have we got, this is just the introduction, and then we will move to the next more technical, I would say, things for the Internet of Things. If you have any questions, please write them